Welcome to the Explainer. Let's set the scene. The clock is ticking, you're in the exam hall, and that intense deadline pressure is absolutely bearing down on you. You've got a complex scenario in front of you from Cambridge AS and A-Level Computer Science Paper 2, specifically subject code 9618. This is the moment where we break down the story, the question itself, and deliver the headline, which is your high-scoring answer. Today, we are opening up the examiner's playbook to look at a highly critical, make-or-break topic, writing records to files. Now, I want to introduce you to two types of students I see all the time. Let's call them Alex and Sam. Alex is the kind of student who overloads their answers with raw computer science facts. They'll dump every line of syntax they've ever memorized onto the page, but there's absolutely zero analysis. On the other hand, we have Sam. Sam rushes against the timer, completely misses the crucial command word requirements, and ends up answering a question the examiner never even asked. When you look at their papers side by side, it's just a sea of red pen marks. We're here today to transform those red marks into green check marks. This explainer isn't just about memorizing some file handling syntax. It's a deep, strategic dive into how this topic is assessed, where students just like Alex and Sam go wrong, and exactly how you can secure those top-tier marks when the pressure is on. 15%. I need you to let that number sink in for a second. That is approximately how much of the total marks in Paper 2 are tied to this single specific topic of writing records to files. Think about that. You've spent years building your foundational knowledge through early syllabus codes like 0417, 0478, 0983, 0984, and 2210. But here in 9618, the stakes are so much higher. Mastering this one area isn't just some minor helpful boost to your score, it is literally a massive foundational pillar for your final grade. You absolutely cannot afford to overlook it or rush through it, like Sam does. When you are under that exam deadline pressure, knowing that 15% of your grade is riding on this one algorithmic concept changes the entire game. We have to be strategic, we have to be exact.
Okay, let's dive into our visual syllabus for today's session. Section 1, Core Principles. Section 2, the Procedural Framework. Section 3, Examiner Warnings. Section 4, Method Marks. And Section 5, Critical Analysis. Let's get right into it.
Section 1, Core Theoretical Principles.
The theoretical architecture of writing records to files rests on three massive pillars: precise definitions, causal relationships, and integration. Now, what does that actually mean for you when you're staring at a blank answer booklet? It means rote learning is dead. It is not enough. This is exactly where Alex fails. Alex memorizes the definition of a record, writes it down, and expects full marks. But the principal examiner reports explicitly state that candidates who reference cross-topic connections achieve significantly higher marks. If you can show how file handling connects to data structures or how writing to a file impacts memory management, the examiner immediately recognizes you as a top-band student. You have to show them that you see the whole board. You have to break down the command words. Are they asking you to describe, explain, or evaluate? And this is where the Peel framework comes into play. Point, evidence, explanation, link. Your precise definitions form your point. The causal relationships are your explanation. The integration with other syllabus areas is your link. If you aren't structuring your theoretical answers with the Peel framework, you are leaving marks on the table.
And this brilliantly illustrates exactly what we are talking about. The assessment framework heavily prioritizes analytical depth over superficial breadth. The academic benchmarks require logical, structured reasoning. Don't just give the examiner a long, rambling list of basic file handling commands. Take one command, one process, and analyze it deeply. Why are you using this specific record structure? Why did you choose this mode of file access, serial, sequential, or random? Depth is where the marks live. When you are writing a paragraph under pressure, you need to use the Peel framework. Make your point about the file access method. Provide your evidence, maybe a snippet of pseudocode. Give your explanation of why it's the most efficient choice. Then link it back to the specific scenario in the question. Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Trust me, integrating that level of analytical depth is what separates the elite students from the rest of the pack. Section 2, the Procedural Framework. When you turn the page and see a massive, complex question on writing records to files, you need a flawless system. You cannot just start writing. Here is the Computer Science Success Blueprint, a 5-step procedural framework directly derived from examiner expectations. Step 1, deconstruct the question. This is where command word decoding happens. Are you being asked to write an algorithm or amend an existing algorithm? Step 2, extract the relevant data from the scenario. What are the field names? What are the data types? Step 3, select your analytical framework or algorithm. Step 4, execute with clear standard notation. And step 5, present your final answer with precise terminology. Do not skip a single one of these steps. Remember Sam? Sam skips straight to step 4, totally misses the command word, and completely blows the answer. This 5-step blueprint is how you guarantee you are answering the question they actually asked, not the one you wish they asked.
Now let's zoom in closely on step 4, execute. Algorithmic thinking requires a very specific, rigorous approach. It demands step-by-step decomposition. You must select the absolutely appropriate data structure for the record you are trying to write. You can't just throw data into an array and hope for the best. Furthermore, efficient code implementation and rigorous testing are completely non-negotiable. The examiners want to see that you can not only write the file handling routine, but that you have actively considered how to test it for errors. Think about it. If you open a file in write mode but the disk is full, what happens? Your code needs to handle that gracefully. This is where your evidence and explanation from the Peel framework shine through in your actual code comments and logic.
Let me share a fantastic insider tactic right from the source material. If you are sitting there and you struggle to remember the exact sequence of operations for writing records under deadline pressure, use a visual story method. Encode the concepts by visualizing the flow of data. Close your eyes and picture the data originating in a variable. See it being structured and packed into a record. Watch it travel through the program. Then visualize your code turning the handle and opening the file door. Picture placing the data neatly inside. And finally, and this is crucial, securely locking the door behind it, which is closing the file. Turning abstract code into a sequential, visual journey makes it stick in your memory so much better than just staring at flashcards. When the timer is counting down, this visual story will save you.
Section 3, Top Examiner Warnings. Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at Ace the Exams IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at Ace the Exams IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, let's get into our interactive workshop for this segment. Listen to this direct quote from a Cambridge senior examiner. Students find multi-step calculations and method marks highly challenging. This right here is a major red flag. When a problem requires you to calculate record sizes, determine file offsets, or loop through multiple complex conditions before finally write into a file, the cognitive load gets incredibly heavy and students just panic. Let's do a quick data scan challenge right now. Imagine you have a complex data table on your paper and a 60-second visual timer is ticking down. You have to extract the core trend. What are the data types? How many bytes does each record take? If you haven't mastered command word decoding, you'll freeze. But now that you know this multi-step calculation is the exact trap the examiner set, you can prepare for it. Break the story down into manageable chunks.
Here are the top 3 fatal mistakes laid out clearly by the examiners. Number 1, using the wrong formula or algorithm for the context. You might read a totally perfect serial file append routine, but what if the question specifically asked for random file access? Boom, 0 marks. Number 2, forgetting boundary conditions and edge cases. What happens when the file is totally empty? What happens when you try to read past the end of the file? You must account for these. Let's play Find the Flaw. If Alex writes a paragraph that says, I will open the file, write the array, and close the file, what's the flaw? The flaw is it lacks boundary condition checks, which leads to mistake number 3, providing generic textbook answers that lack the specific context given in the question prompt. If the prompt is about a hospital database, your answer better mention patients and medical records, not just data item X. Always map your answer back to the scenario using the PEL framework. Link it back.
Section 4, Mastering Method Marks. It's a high anxiety question, isn't it? What if you spend 10 precious minutes on a complex algorithm for writing an array of records to a file? You're doing a speed writing challenge against the clock, and you make one tiny, silly syntax error or a basic arithmetic mistake calculating the file size. Is your final output just completely wrong? Do you lose all 8 or 10 marks for that question? You can feel the tension building just thinking about it, right? This is where deadline pressure crushes students who don't know the system. The answer is a resounding no, provided you follow this massive examiner alert. Method marks can save you. The method mark strategy means that marks are heavily awarded for the analytical process, not just the final output. If you show you're working, if you clearly document your step-by-step decomposition, your loop structures, your variable assignments, your file open and close statements, the examiner can track your logic.
Showing your work can literally save your grade. It can turn a catastrophic 0 out of 8 into a solid 6 out of 8, even with a flawed final output. I cannot stress this enough. Document your process. Let the examiner see the visual story you built in your head.
Section 5. Critical Analysis Strategy. When you are asked to evaluate alternative algorithmic approaches, say comparing 2 different ways to write records to a file, you need a systematic approach. This is where our time management matrix really kicks in. For similarities, you must identify and link them. For differences, use explicit comparative connectives like whereas, however, or conversely. You must support each and every point with evidence from the code, and crucially, draw a solid conclusion about their relative importance. This structured comparison is the absolute pinnacle of the Peel framework. Point, evidence, explanation, link. If you execute this perfectly, you are basically writing exactly what the examiner's mark scheme is looking for. This is how you conquer the highest difficulty command words like evaluate or discuss. It all comes together in this final data interpretation workflow. Deconstruct, solve, evaluate. You identify the given information, often extracting raw data from binary representations first. You break it into logical steps. You solve it systematically, showing all of your working to guarantee those method marks. Then, you pause and check your answer for reasonableness. Does it actually make sense in the real world? Finally, you justify your recommendations based on evidence. That is the complete cycle. That is the 3-rule system that guarantees top marks: command word decoding, Peel framework application, and the time management matrix. I want to leave you with this final provocative thought. Take a hard look at your current study habits. Are you just memorizing algorithms by rote like Alex, just crossing your fingers and hoping the exact same past paper question pops up? Or are you mastering the visual story of the data, truly understanding the theoretical architecture, and flawlessly executing a procedural framework that guarantees method marks even when you make a mistake? The examiner's playbook is now fully in your hands. It's time to completely change how you prepare. Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.